Here we go. All right, 5-1. We're going to use properties of exponents to simplify polynomials. I am not going to be here tomorrow. I'm going to the best place in Texas. Gone for the day. Huh? No. I'm going to the best place in Texas. Best town in Texas. Be gone for the day. Be back on Wednesday. I'll teach you on Wednesday. You'll work again on Thursday. I'll be in a meeting on Thursday. Progress report? Yeah.
Where you going?
College Station. All right, we're going to talk about those properties you were using on the assignment before the holidays. Just kind of brush up on our exponent property rules. The first one we'll talk about is the product rule. Product meaning, what are we doing when we do the product? Multiply. So when I multiply with the same base, what do I do? Oh, dang it. I hate this day. When I multiply with the same base, I add the exponents, yes. What about the quotient rule? Quotient rule says I'm dividing. When I divide with the same base, what do I do with my exponents? Subtract. Then we have what we call the power rule. The power rule is when we have a power to a power. When we have a power to a power, what do we do with our exponents? Multiply them. Then we have the zero power rule. And it says anything to the zero power is simply 1. The negative exponent rule says that if I have a negative exponent that's in the numerator, I'm going to send it to the denominator to make it positive. Or if it's in the denominator as a negative exponent, I'm going to send it to the numerator to make it positive. CJ said the best thing would be for us to go to school till the week before Thanksgiving, then be off till the new year, and then go back to school.
Agreed.
I know. That's really, like, logical.
And then we go into school for an extra week, something in the middle. That's fine.
Okay. I mean, why not put it at the beginning? Go a little bit earlier, 3 weeks.
Agreed.
Go till that. Take a break.
Like,
Agreed.
in the
I
spring
so
break.
agree.
Oh.
Longer than when I thought. You should tell them.
Huh?
I did a longer break than what I thought.
Yeah, that's just not, that didn't do it for me. All right, so let's talk about simplifying monomials. Of course, CJ did get strep over the holiday, so wasn't necessarily the funnest of holidays for him. His best friend called yesterday. I was like, sorry. One more day. All right. Simplifying monomials. Monomials are considered to be simplified when they meet these rules. First thing that they have to have done is that there cannot be any more power to powers. No more powers of powers. The second thing that it must satisfy is that each base must appear exactly once. The third thing that must be true is that all fractions must be in their simplest form. Are you noticing the color scheme yet?
No.
Hey, Nacho's Crocs.
It makes me so happy. All right, and the last thing that must be satisfied are there will be no negative exponents. All right, so we're going to use our rules of exponents and our rules for having a simplified monomial to make sure that we simplify these expressions to the fullest. So I have 2a to the negative 2 power times 3a to the third b squared, and then c to the negative 2 power. So the only operation I have going on here is what?
Multiplication.
Multiplications. Everybody agree? We're just multiplying here. So I'll start by multiplying the numbers. 2 times 3 is 6. And then when I multiply with variables, I'm going to do what with those exponents? Add them. So I have a to the negative 2 plus 3, which is just a, 1a, right? The b and the c didn't have anything to multiply by them. Does everybody agree? The b and the c didn't have anything to multiply by them. But now I have a small problem. That small problem is this negative exponent. So what can I do with c to make that a positive 2 exponent? Move it to the denominator. And there is my simplified expression. Note that I didn't call it a monomial. We'll talk about that in just a minute.
One question.
Go.
On above where you put negative exponent rule, I don't understand why you put you put they put the x on the denominator and then you put or x on the denominator but with the negative exponent. Where you put that?
Oh, up here? If it's in the top, I moved it to the bottom to
Yeah, but-
become positive. If it's in the bottom as a negative, I gotta move it up to the top.
Oh.
Yeah, okay. So I have q squared times r to the 4th over q to the 7th, that's a 7 there, r to the 3rd. So a couple of things I want to talk about. This is what operation? Division, right? Does everybody see we've got division for each of the variables? So that means I'm going to do what with my exponents? Subtract them. So one thing I want to point out, I'm still going to do this the long way, but I want you to note something. When I look at the exponents here, where is the larger exponent for q?
On the bottom.
On the bottom. Guess where q is going to end up?
On the bottom.
On the bottom. What about for r? It's on top, so r is going to end up on top. So we'll look at that, what that looks like. We'll start out by subtracting q to the 2 minus 7, which would be -5. And then r to the 4 minus 3, which is just 1r, right? But what has to happen with the q? Got to move that to the bottom to make it a positive q to the 5th. So I have r over q to the 5th power. Now, I could have skipped this step right here and gone straight to this one just by simply noting what we noted in the beginning. The q was going to end up on the bottom. I just needed to know the difference. So the difference of 7 and 2 was 5. The difference of 4 and 3 was 1. Is everybody with me on that? All right, let's look at the next one. Does everybody have this part? Thank you. All right, simplify the expression.